Murray and Roberts were represented by Professor Morstead from the University of Pretoria. He is a material scientist, so he focused on the behavior of the swivel couplers that were used in the structure. With his introduction, he explained what the temporary works of some terminology that was explained, i.e. what is temporary works, what is false work, and so on. Then they had an introduction with some time-lapse photography which showed how the structure collapsed on the day of the collapse on 14 October 2015. Essentially, the structure appeared to separate at the median supports. That is the center of the highway, where the lattice girders on the eastern side remained stationary for a while, but the lattice girders on the western side moved towards the west and separated from those on the eastern side and landed on the road. Then afterwards, he went into the situation at the various points of support. On the eastern side, there were super shores that were supported on sand jacks, and he explained the purpose of the sand jacks and some distortion that was shown on a photograph that, in my view, was indicative of how the super shores on the eastern side kicked against the sand jacks as the structure was collapsing to the western side. He mentioned that the sand jacks at the median support had not been bolted to the plinths, and then he moved on to explain the role of the swivel clamps that were used to brace the median support and the eastern and western abutments. He didn't use the word abutments, but he focused on some photographs of the swivel clamps and showed some distortion that was visible on the photograph. And what Professor Morstead focused on was swivel clamps that were used to lace this structure together, and also to lace together these abutments which existed on the eastern and western side. So the swivel clamps should really be used to fasten a diagonal member onto other members which are normally vertical, to provide lateral support for the structure. He didn't provide any sketches here to show how the clamps were utilized. This whole aspect of the geometry of the structure was left later to questioning that took place by the Formscaf legal representative, who questioned whether or not the professor had dealt with all aspects of the collapse mechanism, or just some aspects. The professor acknowledged that he'd focused primarily on the behavior of the swivel clamps. So these clamps here are basically intended normally to connect two scaffold tubes together, and they allow rotation, so the angle can vary depending on the circumstances. So what the professor focused on was then testing that had been done in the laboratory to determine whether these clamps comply to the BN 74 standard or not. What they found on site, that there were two types of clamps which both were manufactured or appeared to be manufactured to BN 74, but the older type had a finer thread and the newer type had a coarser thread. And in the tests, it had been found that the newer type had less capacity than the older type. Further, the professor mentioned that 55% of the clamps used at the center median here were of the newer type with lesser capacity. Now these clamps and tubes here had distorted during the collapse. Also, as I mentioned earlier, the time-lapse photography indicated that this section of the deck collapsed round about here. It moved to the west. These columns tipped over, so it moved essentially the same distance as the length of the column. So this side fell down first, and then this side collapsed onto this median support, lying at an angle. So the questioning by the legal representative from Formscaf focused on the fact that the forces that occurred during the collapse could have resulted in the distortion and failure of these clamps, and not necessarily the forces for which they were designed to perform in the correctly behaving structure. The questioning by the Formscaf legal representative has basically made the professor concede that some tests were done in the laboratory don't necessarily apply to the site situation. For example, the slippage of the clamp of 50 millimeters occurred on site, whereas in the laboratory, slippage of in the order of 0 to 8 millimeters occurred. So what the legal representative is trying to imply is that due to a possible poor workmanship, the clamps on site were not tightened sufficiently to withstand the slipping forces to which they were subjected. The professor also used the term some cyclical loads which had been applied to the structure, implying that there was wind that had affected the collapse of the structure. The Professor Morstead admitted that the precise geometry and the precise cyclical forces that he was talking about were modeled by structural analysts who still have to testify, or whose reports still have to be presented. So we are in for some more facts about the structural behavior. The other interesting point that came up is that it was mentioned that there were 7 different types of clamps utilized on site, but they didn't present details of the types of clamps. Now one must point out that there's another type of clamp called a scaffold connector, which is intended to join scaffolds end to end. And now on some photos that I've seen, it is clear that those scaffold connectors were not properly installed because they were installed without securing pins, so they were able to pull out without resisting, without providing any resistance.